Antarctica appears from space as a vast white continent surrounded by the dark waters of the Southern Ocean. Its frozen surface stretches across approximately 14 million square kilometers, making it larger than Europe and almost twice the size of Australia. During the austral winter, the surrounding sea ice expands far beyond the coastline, temporarily increasing the frozen region by millions of square kilometers. From orbit, Antarctica looks empty, smooth, and almost untouched. At ground level, however, the continent is a violent landscape of exposed mountains, moving glaciers, hidden valleys, deep crevasses, and winds powerful enough to erase tracks within minutes. Almost 98% of Antarctica is covered by ice. In many regions, the frozen layer is more than 2 kilometers thick. In the deepest areas, the ice reaches nearly 5 kilometers from the surface to the buried rock below. This enormous mass contains most of the planet's freshwater ice. It also conceals the true shape of the continent. The white surface visible from aircraft and satellites is not the actual land. It is a frozen shell resting above mountain chains, canyons, river systems, basins, and ancient landscapes that have remained hidden for millions of years. The interior of Antarctica is one of the most difficult environments on Earth. Temperatures can fall below -70 degrees Celsius. The air is extremely dry, and the high elevation reduces the amount of oxygen available to researchers. Powerful katabatic winds descend from the elevated interior toward the coast, accelerating as cold, dense air moves downhill. These winds lift loose snow into dense clouds that can hide the horizon and reduce visibility to almost nothing. A scientific station may stand beneath a clear sky in 1 hour and disappear inside a white storm during the next. Most human activity takes place near the coast or around established research stations. Icebreakers approach through seasonal channels in the sea ice. Cargo aircraft land on prepared snow runways. Tracked vehicles carry fuel, food, laboratory equipment, and adult research teams across carefully mapped routes. Beyond these controlled corridors, movement becomes slow and dangerous. Crevasses may be concealed beneath thin bridges of snow. Mechanical failures can become life-threatening. Communication systems depend on satellites, and rescue operations may be delayed by storms lasting several days. The continent's immense scale makes direct exploration difficult. Even modern expeditions can examine only small sections of the terrain. Scientists use satellites, radar, aircraft, seismic instruments, autonomous vehicles, and remote weather stations to gather information across areas that humans rarely enter. Each new survey reveals details that were previously invisible. Some discoveries fit established geological models. Others appear strange when seen in low-resolution satellite images, especially when shadows, snow, and exposed rock create geometric forms. One of the most debated formations lies within the Ellsworth Mountains, a vast mountain system in western Antarctica. The Ellsworth Mountains extend for hundreds of kilometers and contain some of the highest peaks on the continent. Their dark ridges rise above glaciers that flow between steep valleys. From the air, the contrast is dramatic. Black and brown rock breaks through the white surface while long shadows stretch across the snow. In satellite images, one exposed mountain attracted international attention because of its unusually triangular appearance. Viewed from a particular angle, the peak seems to possess several straight edges and broad faces that meet near a central summit. Snow fills the surrounding valleys, making the dark rock appear isolated above a smooth frozen plain. The formation resembles a large pyramid emerging from the Antarctic ice. The image spread rapidly across websites, documentaries, and online forums. Some observers compared the mountain with the pyramids of Egypt. Others suggested that its proportions appeared too regular to be accidental. Enlarged satellite photographs seemed to show 4 triangular faces. The summit appeared centered, and the ridgelines seemed to descend at similar angles. To people already convinced that Antarctica once supported an unknown civilization, the mountain looked like physical evidence hidden in plain sight. Geologists offered a more conventional explanation. The formation is likely a nunatak, a mountain peak or rocky ridge that rises above a surrounding glacier or ice sheet. Nunataks are common in Antarctica. They appear when the highest parts of a mountain remain exposed while lower slopes and valleys become buried beneath moving ice. From a distance, a nunatak may look like an isolated island of rock inside an ocean of snow. The pyramid-like shape can develop through natural erosion. Mountains are fractured by geological forces long before ice covers them. Water enters cracks during warmer periods. When temperatures fall, the water freezes and expands. This repeated process breaks the rock apart. Strong winds remove loose material. Glaciers grind against the lower slopes. Snow and ice accumulate differently on each face depending on sunlight, wind direction, and elevation. Over long periods, erosion may follow existing fractures and produce several steep faces around the summit. Similar formations can be found in the Alps, the Himalayas, Greenland, Patagonia, and other mountain regions. The Matterhorn, for example, possesses a sharply pyramidal form shaped by glaciers eroding different sides of the same peak. Its geometry is striking, but it is entirely natural. The Ellsworth Mountains were also shaped by tectonic forces. Layers of sedimentary rock were compressed, folded, fractured, and uplifted over immense geological periods. Erosion then exposed resistant sections while weaker material disappeared. When viewed from the correct direction, intersecting ridges can create the appearance of precise symmetry. A slight change in viewing angle may reveal that the faces are not equal and that the summit is less regular than it first appeared. Lighting also affects the interpretation. Satellite images capture the surface at specific times of day. Low sunlight produces long, sharp shadows. These shadows can hide irregular slopes and emphasize straight ridges. Snow fills depressions and covers smaller rock features, simplifying the shape. A complex mountain can therefore appear cleaner and more geometric than it would from the ground. However, the natural explanation did not end the debate. Supporters of the artificial pyramid theory focused on the apparent alignment of the faces. They argued that erosion rarely creates such a balanced form. Some suggested that only the upper section of a larger structure remained visible, while the lower portion was buried beneath the ice. In this interpretation, the exposed peak was not an entire pyramid but the summit of a monument constructed before Antarctica became frozen. No excavation has confirmed this idea. No blocks, chambers, tools, inscriptions, roads, or associated ruins have been documented at the site. There's also no verified archaeological evidence showing that an advanced human civilization occupied Antarctica before the formation of the modern ice sheet. The mountain remains inaccessible to most independent investigators, but distance alone is not evidence of artificial construction. The controversy reveals how easily Antarctica encourages speculation. The continent contains real geological structures that are difficult to examine directly. Satellite platforms provide images, but those images may lack detail, depth, or consistent lighting. People studying them from thousands of kilometers away often interpret the shapes according to their expectations. A geologist sees fractures, ridges, and glacial erosion. A theorist sees architecture. The pyramid-like mountain is not the only formation that has attracted attention. In other satellite images, observers have identified dark openings in snow-covered slopes. One widely circulated image appears to show a rectangular entrance cut into the side of a mountain. The opening looks almost black against the surrounding ice. Its upper and lower edges appear horizontal, while the sides seem nearly vertical. From above, it resembles a doorway leading into the rock. Some interpretations describe the opening as the entrance to an underground base. Others call it a tunnel, hangar, or ancient chamber. Enlarged images often increase the contrast, making the shape look more defined. Arrows and outlines are added to emphasize the supposed geometry. Once the object is presented as a doorway, it becomes difficult for viewers to see it as anything else. Natural processes can create similar forms. Rock fractures often meet at sharp angles. A section of a cliff may collapse along these fractures, leaving a dark recess. Snow can accumulate around the opening and create straight-looking borders. Shadows hide the uneven interior. From the limited perspective of a satellite, a shallow cavity can appear to be a deep tunnel. Ice itself may also create temporary openings. Meltwater channels can form during warmer periods. Wind can carve cavities beneath hardened snow. A glacier pulling away from a rock face may leave a gap that appears dark and rectangular. These openings can change or disappear as snow moves across the slope. In some cases, satellite images taken in different years show the same area with different features. A dark opening visible in one image may later be covered. A line that resembles a wall may vanish beneath drifting snow. This change is sometimes interpreted as deliberate concealment. A more direct explanation is that Antarctica's surface is constantly moving. Wind redistributes snow. Glaciers advance. Ice breaks. Seasonal sunlight changes the direction of shadows. Other images appear to show caves beneath mountain ridges. Dark arches are visible at the boundary between rock and ice. Some are genuine ice caves formed by flowing water, geothermal heat, wind erosion, or the movement of glaciers. Ice caves can extend far beneath the surface, but their passages are unstable. Ceilings collapse, entrances close, and new tunnels appear as the frozen landscape changes. Scientists are deeply interested in Antarctic caves because some may contain unusual microorganisms, preserved sediments, and evidence of past climates. In volcanic regions such as Mount Erebus, geothermal heat can create networks of subglacial cavities. Warm vapor rises through fractures, melting spaces beneath the ice. These environments may contain temperatures significantly higher than the surface outside. They are scientifically important, but they do not prove the existence of hidden cities or artificial bases. Satellite observers have also reported horizontal lines resembling giant steps on exposed slopes. In several images, parallel bands cross a mountainside at regular intervals. Snow rests on the flat surfaces while darker rock appears along the edges. From a distance, the formation resembles a staircase built for beings much larger than humans. Layered rock can naturally produce this appearance. Sedimentary formations often contain alternating bands of hard and soft material. Erosion removes the weaker layers more quickly, leaving terraces. When snow settles on the flatter sections, the pattern becomes more visible. Freeze-thaw cycles can also fracture cliffs along horizontal planes. The resulting ledges may look artificial even when their origin is entirely geological. Glacial movement creates additional patterns. Ice pressing against a slope can polish some surfaces and tear material from others. Meltwater may cut channels across exposed rock. Repeated snow accumulation can produce lines that follow the shape of the terrain. From high above, these natural features lose scale. A ledge only a few meters high can appear monumental. The lack of scale is a major problem in interpreting satellite images. Without nearby buildings, vehicles, trees, or people, the size of a feature may be impossible to judge. A dark shape believed to be a massive entrance could be a narrow crack. A supposed tower could be a small rock. A long wall may be the edge of a shadow extending across uneven snow. Image compression creates further distortions. Satellite maps often combine photographs captured on different days, from different angles, and under different lighting conditions. Software aligns these images to create a continuous surface. At the boundaries, shapes may stretch or repeat. Blurred sections can form straight edges. Areas with limited data may be represented by lower resolution images that create artificial patterns. Despite these technical limitations, the visual mysteries continue to attract attention because the setting remains physically inaccessible. In most parts of the world, a strange geological formation can be visited, photographed from the ground, measured, and sampled. In Antarctica, reaching a single remote mountain may require international coordination, specialized aircraft, trained crews, survival equipment, environmental authorization, and favorable weather. The cost can be enormous. This distance creates a space between observation and confirmation. The satellite image exists, but direct evidence remains absent. That space is filled by competing explanations. Scientists build interpretations from geology, glaciology, climate data, and comparisons with known formations. Alternative researchers connect the images with stories of lost civilizations, secret expeditions, and ancient maps. The mystery becomes more powerful because the visible surface represents only a small part of the continent. Beneath the ice lies a buried landscape larger than many nations. Radar surveys have revealed mountain ranges completely covered by frozen layers. Deep valleys extend beneath the central ice sheet. Some basins descend below sea level. Ancient channels suggest that rivers once crossed areas now sealed beneath kilometers of ice. Aircraft equipped with ice-penetrating radar fly in long, precise lines across the continent. The radar sends energy through the ice and records reflections from the rock below. Scientists convert these signals into maps of the buried terrain. The results reveal a continent with steep mountains, broad plains, deep canyons, and complex drainage systems. One of the most remarkable discoveries is the Gamburtsev subglacial mountains, a range hidden beneath the East Antarctic ice sheet. These mountains are comparable in scale to major ranges above the surface, yet they remain completely buried. Their existence demonstrates how little the visible Antarctic landscape reveals about the land below. The ice is not a motionless cover. It flows slowly from the elevated interior toward the coast. Some glaciers move only a few meters each year. Others advance much faster. Their movement reshapes the buried terrain and transports enormous quantities of ice toward the ocean. Internal layers bend, fracture, and fold under pressure. Subglacial water reduces friction and allows sections of the ice sheet to move more rapidly. Above this dynamic system, the surface may appear silent and permanent. Aerial footage shows smooth plains extending to the horizon. Dark mountain peaks rise through the white surface. A distant research station stands alone beneath a pale sky. Yet below the aircraft, the ice may conceal valleys deeper than the Grand Canyon, lakes isolated from the atmosphere, and rock surfaces that have not been exposed to sunlight for millions of years. This hidden geography gives the Antarctic mysteries their strongest foundation. The artificial pyramid has not been proven. The rectangular entrances may be shadows, fractures, or ice caves. The stair-like formations may be layered rock. But the existence of unknown and inaccessible terrain is not speculation. It is a confirmed reality. Every improvement in satellite resolution reveals new details. Every radar survey changes the map beneath the ice. Scientific teams continue to identify buried mountains, channels, lakes, and ancient surfaces. Most discoveries have natural explanations, but they also demonstrate that Antarctica still contains large areas that have never been directly examined. The central question is therefore larger than a single pyramid-shaped peak. It concerns the scale of what remains unseen. Almost the entire continental surface lies beneath a frozen layer that can reach several kilometers in thickness. The exposed mountains are only fragments of a much larger landscape. The four-faced peak in the Ellsworth Mountains stands above the ice as a visible symbol of that hidden world. Geology provides a strong explanation for its shape. Erosion, glacial action, rock fractures, wind, snow, and perspective can produce the appearance seen in satellite images. No verified evidence currently identifies it as an artificial monument. Yet the mountain continues to provoke questions because it rises from a continent whose true surface cannot be seen. Around it, dark openings appear and disappear beneath drifting snow. Caves extend under glaciers. Horizontal rock layers resemble steps. Shadows transform irregular cliffs into geometric walls. The most important mystery is not whether every unusual shape is artificial. The greater mystery is that millions of square kilometers of land remain sealed beneath ice, beyond direct observation. Mountains, valleys, ancient river systems, and geological records lie below the frozen surface. Some have been detected by instruments. Others remain unmapped. Antarctica is not an empty white plain. It is a buried continent. The peaks visible above the ice are only the highest points of a hidden world, and the deeper history of that world begins long before Antarctica became the coldest place on Earth. The frozen surface of Antarctica creates the impression that the continent has always existed in its present form. Endless ice fields, exposed black mountains, violent winds, and months of darkness seem permanent. Yet beneath this modern landscape lies evidence of a radically different world. Antarctica was not always a polar desert. For long periods in Earth's history, forests covered parts of the continent, rivers crossed broad plains, and vegetation grew beneath a climate far warmer than anything found there today. Scientists discovered some of the earliest evidence in exposed rock formations along the Transantarctic Mountains. Adult researchers climbed across steep ridges where the wind had removed loose snow and revealed ancient sedimentary layers. Inside these rocks, they found fossilized leaves, fragments of wood, pollen grains, roots, and tree trunks still positioned where they had once grown. These remains were not transported from another continent. They belonged to ecosystems that had developed on Antarctic soil. Some fossilized trunks remain upright, locked inside ancient layers of sediment. Their position allows paleobotanists to reconstruct the forests that once surrounded them. The trees grew close together in damp ground. Their roots extended through soils formed beneath a much milder climate. Fallen leaves accumulated on the forest floor. Rivers carried mud and organic material into low-lying basins. Over time, sediment buried the vegetation and preserved it as stone. The fossils belong to several different periods. Some date from more than 200 million years ago, when Antarctica formed part of the southern supercontinent Gondwana. At that time, Antarctica was connected to South America, Africa, India, Australia, and other landmasses. Plant and animal species could move across regions that are now separated by enormous oceans. During parts of the Permian period, forests of Glossopteris covered large areas of Gondwana. Glossopteris was a seed-producing plant with long, tongue-shaped leaves. Fossils of the same plant have been found in Antarctica, South America, Africa, India, and Australia. Their distribution became important evidence supporting the idea that these continents had once been joined. A reconstruction of Antarctica during this period would not show a completely tropical world. The continent already occupied high southern latitudes, and its ecosystems experienced long seasonal changes in sunlight. During summer, daylight could continue for months. During winter, darkness could dominate the landscape. Yet the climate was warm enough for forests to survive. The trees adapted to these extreme light cycles. Some grew rapidly during the bright summer and entered a dormant state during the dark winter. Their fossilized growth rings record this rhythm. Wide sections indicate periods of active growth. Narrow boundaries mark seasonal pauses. The trees endured months without direct sunlight, but they did not face the permanent deep freeze that defines Antarctica today. Later geological periods brought other forms of vegetation. Fossil pollen shows that flowering plants, ferns, mosses, and conifers once grew in Antarctic environments. On islands near the Antarctic Peninsula, scientists have uncovered leaves and wood from forests that existed tens of millions of years ago. These fossils reveal that the region supported complex ecosystems even after the age of dinosaurs. During the Cretaceous period, parts of Antarctica experienced a temperate climate. Atmospheric carbon dioxide levels were much higher than modern levels, and global temperatures were warmer. There were no permanent ice sheets comparable to those covering the continent today. Rivers flowed toward coastal plains. Forests extended across valleys. Dinosaurs and other animals moved through landscapes that would now be buried beneath ice. A visual reconstruction shows tall trees rising from wet ground beneath a pale polar sky. Ferns cover the forest floor. Slow rivers wind through broad plains. Seasonal rain falls over dark soil. The sun remains near the horizon during long summer days. Months later, the same forest enters prolonged darkness, but temperatures remain high enough for the trees to survive. The idea of forests growing near the South Pole may appear impossible, but the fossil evidence is clear. Antarctica once supported vegetation under environmental conditions very different from those of the present. The more difficult question is how this green continent became covered by one of the largest ice sheets in Earth's history. The transformation did not occur in a single catastrophic moment. It developed gradually through changes in continental position, ocean circulation, atmospheric chemistry, and global temperature. Antarctica slowly separated from the other fragments of Gondwana. South America moved away from the Antarctic peninsula. Australia also drifted northward, opening new ocean passages around the southern continent. These separations changed the movement of ocean water. Once Antarctica became geographically isolated, a powerful current began to circulate around it. The Antarctic circumpolar current moved continuously from west to east without being blocked by a major continent. This current reduced the transfer of warmer tropical water toward Antarctica and helped isolate the continent climatically. At the same time, atmospheric carbon dioxide levels declined over millions of years. Lower greenhouse gas concentrations allowed global temperatures to fall. Ice began to form in elevated regions of East Antarctica. Glaciers expanded down mountain valleys. During colder intervals, separate ice masses joined together. The frozen cover spread across increasingly large areas of the continent. By approximately 34 million years ago, near the boundary between the Eocene and Oligocene epochs, a major Antarctic ice sheet had developed. The landscape did not immediately become identical to the modern continent. The ice advanced and retreated many times. Warmer periods reduced the frozen cover. Colder periods allowed glaciers to expand again. Sediments from the ocean floor preserve evidence of these changes. Research ships drill through layers beneath the Southern Ocean and recover long cylindrical cores. Each section contains fragments of rock, microscopic fossils, chemical signals, and organic material deposited during a different period. These records show when glaciers reached the coast, when warmer waters entered the region, and when vegetation persisted near the margins. Modern drilling projects have also recovered sediments from beneath Antarctic ice. Adult scientific teams operate heavy equipment on the frozen surface while winds push snow across the worksite. Drills descend through ice and sediment. The recovered material is placed in sterile containers and transported to laboratories. Under microscopes, researchers identify pollen grains that once traveled through ancient forests. One remarkable discovery came from sediments buried beneath the seabed of West Antarctica. Researchers found fossil pollen, roots, and spores indicating that a swampy temperate rainforest existed near the South Pole approximately 90 million years ago. The reconstructed environment included dense vegetation, rivers, and soils rich in organic material. This forest grew during a period when dinosaurs still lived on Earth. The region experienced months of darkness during winter, yet temperatures remained mild enough to prevent permanent freezing. Climate models suggest that the atmosphere contained much more carbon dioxide than it does today. The discovery provides a visible warning of how strongly greenhouse gases can transform polar regions. As the Antarctic ice sheet expanded, it buried the older landscapes. Valleys filled with ice. Rivers disappeared beneath glaciers. Mountains became covered until only their highest peaks remained exposed. Forests were crushed, eroded, or sealed beneath sediment and frozen layers. In some locations, the ice may have protected ancient surfaces from later weathering. Today, scientists search for these buried landscapes using airborne radar. Aircraft cross Antarctica along carefully planned lines. Long instruments mounted beneath the wings transmit radio waves into the ice. Most of the energy passes through the frozen layers. When the signal reaches rock, water, or sediment, part of it returns to the aircraft. The reflected signals reveal differences in depth and structure. Scientists convert the measurements into three-dimensional maps. On computer screens, the smooth white surface disappears. Beneath it, valleys descend between mountain ridges. Broad basins stretch across the interior. Ancient channels branch like river networks. In East Antarctica, radar surveys have identified landscapes that appear to have been shaped by rivers before the ice sheet formed. Long valleys connect elevated regions with lower basins. Their smooth profiles differ from features carved entirely by glaciers. Some surfaces may have remained protected beneath cold, slow-moving ice for tens of millions of years. One buried region contains a network of valleys and ridges covering an area larger than some European countries. Researchers believe the landscape may have formed when rivers flowed across Antarctica before permanent glaciation. Later, ice covered the terrain without completely destroying its original shape. These findings do not prove that human beings or an unknown civilization lived there. The landscapes are far older than the known existence of modern humans. However, they demonstrate that Antarctica once contained environments capable of supporting complex life. Forests, wetlands, rivers, and coastal ecosystems existed where only ice is visible today. The difference between biological possibility and archaeological evidence is essential. A warm ancient Antarctica could support plants, insects, reptiles, dinosaurs, birds, and other animals appropriate to its geological period. It does not automatically imply cities, monuments, or advanced technology. No confirmed archaeological settlement has been discovered beneath the Antarctic ice. Still, the existence of buried terrain creates legitimate scientific questions. Organic material may remain preserved in ancient sediments. Fossils could reveal species unknown from other continents. Subglacial basins may contain records of climate transitions. Isolated rock formations could preserve evidence from periods that are poorly documented elsewhere. The image of a hidden green Antarctica also influenced the interpretation of one of history's most controversial maps. In 1929, a fragment of an early 16th century map was discovered in the Topkapi Palace in Istanbul. The document had been created in 1513 by the Ottoman admiral and cartographer Piri Reis. The surviving fragment was drawn on animal skin. It showed parts of the Atlantic Ocean, the western coasts of Europe and Africa, and the eastern coast of South America. Decorative ships, animals, and written notes appeared across the surface. Piri Reis explained that he had compiled the map using several older sources, including Portuguese charts and maps associated with earlier explorers. The southern section became the center of modern controversy. A coastline extends eastward from South America and curves across the lower part of the map. Some observers argue that this shape represented the coast of Antarctica without its ice. According to this interpretation, the map preserved geographic information collected before the continent became frozen. The theory gained attention through Charles Hapgood, an American professor who published his ideas during the 20th century. Hapgood argued that ancient civilizations may have possessed advanced geographic knowledge inherited from an unknown earlier culture. He believed the Piri Reis map and other historical charts contained accurate details of coastlines that had not yet been officially explored by Europeans. Hapgood compared the southern coastline on the map with modern reconstructions of Antarctica. He suggested that the map showed Queen Maud Land and other coastal features hidden beneath the ice. Because Antarctica was not officially sighted until the 19th century, such a representation would imply access to much older source material. A dramatic reconstruction shows the Piri Reis map opened on a wooden table beneath warm lamplight. The parchment is cracked and discolored. An adult researcher follows the southern coastline with a gloved finger. Beside the map lies a modern satellite image of Antarctica. The two coastlines appear to share several broad curves. This visual comparison is compelling, but many historians and cartographers reject Hapgood's conclusion. They argue that the southern landmass is more likely a distorted continuation of South America. Early mapmakers often stretched, rotated, or compressed coastlines because they worked with incomplete measurements. The lower section may combine speculation, copied errors, and misunderstood geographic reports. The Piri Reis map contains clear inaccuracies. Distances are inconsistent. Some islands appear in incorrect positions. The shape of South America is distorted. Parts of different source maps were joined using different scales and orientations. Similarity between one section and Antarctica may result from selective comparison rather than precise correspondence. Historians also note that early European maps sometimes depicted a hypothetical southern continent. Ancient and medieval scholars believed that a large landmass might exist in the south to balance the known lands of the northern hemisphere. Cartographers drew versions of this unknown region long before Antarctica was observed. These shapes were based on theory, not direct exploration. The map itself does not identify the southern coastline as Antarctica. No note from Piri Reis describes an ice-free polar continent. The interpretation emerged centuries later. The document is historically important because it shows how geographic knowledge circulated among early modern sailors and mapmakers, but it is not accepted as proof of a lost Antarctic civilization. Hapgood developed a broader theory to explain how a civilization could have mapped Antarctica before it became frozen. He proposed that the outer shell of Earth could shift relative to the planet's interior, rapidly moving continents into new climatic zones. In this model, Antarctica may once have occupied a warmer position before being displaced toward the South Pole. He called this idea Earth crust displacement. Hapgood believed a large accumulation of polar ice could destabilize the crust and cause a sudden global shift. Continents would move over the planet's deeper layers. Regions could change latitude quickly, producing dramatic climatic transformations and destroying civilizations. Albert Einstein wrote a foreword for one of Hapgood's books and considered the general problem interesting. However, this association is sometimes presented misleadingly. Einstein's interest did not validate the theory, and modern geology does not accept rapid global crust displacement as an explanation for Antarctica's location. Plate tectonics provides a different model supported by extensive evidence. Continents move because rigid plates travel slowly across Earth's mantle. This movement usually occurs at rates measured in centimeters per year. Antarctica's position changed over hundreds of millions of years, not through a sudden recent displacement of the entire crust. True polar wander and changes in Earth's rotational axis can occur, but these processes differ from Hapgood's proposed mechanism. Magnetic poles also shift in reverse, but magnetic movement does not physically relocate continents. Confusion between geographic poles, magnetic poles, and moving tectonic plates often gives speculative theories an appearance of scientific support. Antarctica's climate changed because of several interacting processes. Continental drift moved the landmass toward the south over geological time. Ocean gateways opened as Australia and South America separated from Antarctica. The Antarctic circumpolar current strengthened. Atmospheric carbon dioxide declined. Ice reflected more sunlight into space, reinforcing the cooling process. These mechanisms are supported by rock records, marine sediments, fossil evidence, isotope measurements, and climate models. They explain why the continent gradually changed from a vegetated environment into a frozen one. They do not require a sudden displacement during the age of human civilization. Yet the concept of rapid pole shifts remains popular because it provides a dramatic explanation for ancient maps, lost lands, and global catastrophes. It appears in books, online videos, and alternative historical theories. The idea often connects Antarctica with Atlantis or other legendary civilizations, even though no verified archaeological evidence supports such a link. The discussion sometimes includes predictions attributed to Edgar Cayce, an American psychic active during the early 20th century. Cayce entered trance-like states and delivered statements on health, spirituality, ancient history, and future events. Later followers claimed that some of his readings predicted major Earth changes, shifting coastlines, and the reappearance of lost lands. Certain interpretations connect Cayce's statements with Antarctica. They suggest that geological transformation or melting ice could reveal ancient records beneath the continent. These claims are not scientific predictions. They are spiritual or prophetic interpretations whose wording is often vague and whose later retellings vary significantly. No credible geological evidence shows that Cayce possessed knowledge of a hidden Antarctic civilization. His predictions cannot replace measurable observations, dated sediments, radar surveys, or archaeological remains. They belong to the cultural history of alternative belief, not to established Antarctic science. Even so, such predictions remain influential because they connect a real scientific transformation with the possibility of hidden history. Antarctica is changing. Glaciers are retreating in some regions. Previously covered rock is becoming exposed. Satellite surveys are revealing structures beneath the ice. These real developments allow older myths to be reinterpreted as approaching discoveries. The scientific reality is already extraordinary without requiring a lost city. Antarctica contains fossil forests near the South Pole. It preserves soils formed under greenhouse climates. It hides ancient river valleys beneath kilometers of ice. Its rocks record the breakup of Gondwana. Its sediments reveal transitions between warm and frozen worlds. Researchers examine fossil leaves to estimate past temperatures. The shape and density of pores on a leaf can indicate the concentration of carbon dioxide in the ancient atmosphere. Pollen identifies plant families. Tree rings reveal seasonal growth. Sediments indicate whether a region was once a river, lake, swamp, forest, or coastal environment. These details allow scientists to reconstruct scenes that no human witnessed. A river moves slowly across an Antarctic plain. Tall conifers rise near its banks. Ferns grow beneath the trees. Rain falls during a warm polar summer. Farther inland, animals cross damp soil. During winter, darkness lasts for weeks, but the forest survives. Millions of years pass. Carbon dioxide declines. The ocean current around Antarctica strengthens. Snow remains on elevated mountains through summer. Glaciers descend into valleys. Forests retreat toward the coast. Rivers become blocked by ice. The white surface expands until it covers almost the entire continent. The transition took place over geological time, with advances and retreats controlled by changes in climate. Ice sheets carve some landscapes while preserving others. In West Antarctica, the weight of the ice pushed parts of the bedrock below sea level. In East Antarctica, ancient highlands remained buried beneath a colder and more stable ice sheet. The frozen cover now acts as both a barrier and a protective archive. It prevents direct access, but it may also preserve ancient sediment, microorganisms, fossils, and landforms. Areas beneath cold-based ice experience little melting at the ground. Without liquid water to produce strong erosion, delicate landscapes can survive for millions of years. Radar maps reveal only their broad form. To determine their age and composition, scientists would need direct samples. Drilling through several kilometers of ice is technically difficult and expensive. Researchers must also avoid contaminating isolated environments with modern microbes, fuel, drilling fluid, or equipment. Environmental rules require careful planning. Every expedition must minimize waste and damage. Equipment must survive extreme temperatures. Drilling sites may be hundreds of kilometers from the nearest permanent station. Weather can interrupt operations without warning. A project designed to recover a small amount of sediment may require years of preparation. These obstacles explain why so much remains unknown. The absence of direct evidence is not proof that extraordinary structures exist, but it also means that the buried landscape has not been fully examined. Scientific uncertainty is real. It must be distinguished from claims unsupported by physical evidence. The Piri-Reis map does not confirm an ice-free Antarctic coast. Earth crust displacement is not accepted as the cause of Antarctica's glaciation. Edgar Cayce's predictions are not scientific data. Yet the underlying history of a warmer Antarctica is verified by fossils, sediments, and geological analysis. This distinction makes the continent more compelling, not less. Antarctica contains a confirmed lost world, but it is a natural world of forests, rivers, wetlands, and changing climates. Its existence reveals how dramatically Earth can transform across time. A fossil leaf held beneath a laboratory light is evidence of that transformation. The fine veins remain visible in the stone. Pollen extracted from buried sediment identifies plants that no longer grow anywhere near the continent. A radar profile displays a valley beneath the ice. Its shape suggests water once flowed through it before the glaciers arrived. Above these discoveries, the modern surface remains severe. Snow moves across the plateau. Mountains rise through the ice. A research aircraft follows a straight path over an invisible river system. Instruments record the buried landscape while the crew sees only white emptiness below. The deeper scientists look, the clearer the ancient continent becomes. They can trace mountain ranges that guided old rivers. They can locate basins where lakes or swamps may have formed. They can identify sediments deposited before the major ice sheets developed. Each discovery adds detail to a world erased from the surface. The unresolved question is not whether Antarctica was once green. That that is supported by abundant evidence. The unresolved question is how much of that ancient environment remains preserved beneath the ice and what its sediments may contain. There may be fossil ecosystems unknown to science. There may be continuous climate records extending across periods of extreme warmth. There may be evidence showing how forests responded to months of polar darkness. There may be microorganisms preserved in isolated layers. There may be geological structures that reveal how quickly the ice sheet formed and how vulnerable it remains today. None of these possibilities requires an ancient human civilization. They are scientifically plausible mysteries based on known geology and incomplete exploration. Yet because the landscape is hidden, it continues to attract more dramatic interpretations. The old map, the speculative theories, and the prophetic claims all emerge from the same visual contrast. Modern Antarctica appears lifeless and permanent, but its rocks prove that this appearance is temporary on the scale of Earth's history. The continent changed before, and it can change again. Beneath the ice, valleys remain where rivers once flowed. Buried soils preserve roots from vanished forests. Fossil pollen records plants that grew under a warm polar climate. Mountain ridges form the boundaries of landscapes no living person has ever seen. The ice did not erase the former continent completely. It covered it. And beneath that cover, Antarctica preserves the physical remains of a world that existed long before the first human map was drawn. Beneath the Antarctic ice sheet, liquid water still moves through a hidden world of lakes, channels, and buried basins. Scientists have identified more than 400 subglacial lakes beneath Antarctica. Some are small pockets of water trapped under local glaciers. Others extend across vast areas beneath several kilometers of ice. These lakes remain liquid because of pressure, geothermal heat, and friction between the moving ice and the bedrock. The enormous weight of the ice lowers the melting point slightly, while heat rising from Earth's interior warms the base of the glacier. The most famous example is Lake Vostok. Lake Vostok lies beneath East Antarctica, close to the Russian Vostok Station. Almost 4 kilometers of ice separate the station from the water below. Radar measurements revealed a broad, smooth reflection beneath the surface, confirming the presence of one of the largest known subglacial lakes on Earth. The lake extends for hundreds of kilometers and may reach more than 1 kilometer in depth. It has remained isolated from direct contact with the atmosphere for an immense period. Scientists wanted to know whether life could survive there without sunlight. Drilling toward Lake Vostok required years of work. Adult researchers operated heavy equipment under extreme cold. Each section of ice brought to the surface was measured, photographed, and stored. The greatest challenge was contamination. Traditional drilling fluids and surface microorganisms could enter the lake and damage an environment that may have remained isolated for millions of years. Researchers therefore attempted to allow lake water to rise naturally into the borehole and freeze before samples were recovered. In 2012, the drilling project reached the lake. Water entered the lower borehole and later froze. Early studies detected possible biological material, but contamination made the results difficult to interpret. Some genetic sequences may have come from drilling equipment, fluids, or laboratory environments. Lake Vostok remains scientifically important, but the exact nature of its ecosystem has not yet been fully established. Other projects developed cleaner methods. Subglacial Lake Mercer lies beneath West Antarctica. Researchers created a temporary scientific camp above the lake and used filtered, sterilized hot water to melt a narrow shaft through more than 1 kilometer of ice. Sampling instruments descended through the borehole. The recovered water and sediment contained active microbial communities. These organisms survived without sunlight by using chemical energy from carbon, sulfur, nitrogen, iron, and other compounds. The discovery confirmed that life can exist beneath the Antarctic ice sheet. Lake Mercer also contained ancient marine material in its sediment. This evidence may record periods when the region was connected to the ocean or covered by different forms of ice. Lake Enigma revealed another unusual ecosystem. The lake is covered by permanent ice, but liquid water remains below. Scientists drilled through the surface and discovered complex microbial mats on the lake floor. These communities formed layered structures and survived under cold, dark, nutrient-poor conditions. The organisms beneath Antarctic lakes do not depend on photosynthesis. They use chemical reactions between water, rock, minerals, and organic material. Subglacial water also moves between lakes. Satellite measurements show that the ice surface rises when water accumulates below and falls when the water drains into another basin. This movement reveals an interconnected hydrological system beneath the continent. Some rivers flow through channels. Others move through saturated sediment or cavities between ice and rock. This hidden water affects glacier movement. When water reduces friction beneath a glacier, the ice can accelerate toward the ocean. Understanding these systems is therefore essential for predicting future sea level rise. Complex life also survives beneath Antarctic ice shelves. Ice shelves float over the ocean and block sunlight from reaching the water below. For years, scientists believed that animals living far from open water would have little food. Cameras lowered through drilled holes revealed a different reality. Beneath the Filchneron ice shelf, researchers discovered animals attached to a rock on the dark seafloor. Some appeared to be sponges and other filter-feeding organisms. Their existence showed that ocean currents can transport nutrients far beneath floating ice. Fish also live in these environments. Some Antarctic fish produce antifreeze proteins that prevent ice crystals from growing inside their body fluids. These adaptations allow them to survive in seawater close to its freezing point. Octopuses move across the dark seafloor. Sea spiders walk between sponges and corals. Crustaceans hide inside sediment. These animals depend on currents carrying oxygen and food beneath the ice. Robotic vehicles now enter some of these cavities. Autonomous underwater machines measure temperature, salinity, currents, and the shape of the ice above. Their sonar systems reveal channels and terraces carved into the underside of ice shelves. These observations show how warm ocean water melts the ice from below. One of Antarctica's most dramatic visible features is blood falls. Blood falls emerges from Taylor Glacier in the McMurdo Dry Valleys. Dark red water flows from a fracture and spreads across the white ice. The color once appeared mysterious, but scientists identified the cause. A reservoir of extremely salty water lies beneath the glacier. The brine contains dissolved iron. When the water reaches the surface, the iron reacts with oxygen and produces rust-colored compounds. The glacier appears to bleed, but the process is chemical. The brine also contains microorganisms. These organisms survive without sunlight and with very little oxygen. They obtain energy through reactions involving iron and sulfur. Blood falls demonstrates that cold, salty water beneath ice can remain active and biologically inhabited. These discoveries have changed how scientists search for life beyond Earth. Jupiter's moon Europa likely contains an ocean beneath its frozen surface. Saturn's moon Enceladus releases plumes of water, salts, and organic compounds from an internal ocean. Lake Vostok provides a model for a large body of water beneath thick ice. Lake Mercer shows that microorganisms can survive through chemical energy. Lake Enigma demonstrates that stable microbial communities can form beneath permanent ice. Blood Falls reveals that salty, iron-rich environments may support life without sunlight. No life has been confirmed on Europa or Enceladus. Antarctica only demonstrates that such survival is physically possible. Space agencies test instruments and drilling methods in polar environments because future missions must reach hidden oceans without contaminating them. The same problem exists in Antarctica. A single unclean tool can introduce modern bacteria into an isolated lake. Every sample must therefore be collected, stored, and analyzed with extreme care. Most Antarctic subglacial lakes remain unexplored. Many are known only through radar reflections or changes in the surface above. Their chemistry, biology, and sedimentary records remain unknown. Beneath the visible frozen desert lies another continent of water and life. The surface receives sunlight during summer. The hidden lakes remain permanently dark. The surface appears motionless. The buried rivers continue to flow. Lake Vostok, Lake Mercer, Lake Enigma, Blood Falls, and the ecosystems beneath ice shelves reveal that Antarctica is not biologically empty. It contains living environments sealed beneath ice, maintained by pressure, heat, salt, rock, and time. These ecosystems do not confirm hidden civilizations or unknown giant creatures. They reveal something more important. Life can survive in places once considered impossible. Antarctica's physical conditions create a powerful environment for legends. Extreme cold, darkness, exhaustion, isolation, poor visibility, and danger can alter human perception. A shadow may appear to move. A sound carried by the wind may resemble footsteps. A pale shape beneath the ocean may be interpreted as an unknown creature. One of the most recent legends is the Nin-Jin. The story became popular through Japanese online forums. According to the accounts, crews aboard research or fishing vessels saw enormous white forms moving through Antarctic waters. Descriptions varied. Some witnesses described a smooth white body with long arms. Others reported a whale-like tail, dark eyes, a human-shaped head, or lower limbs resembling legs. No consistent anatomy appeared across the stories. A reconstruction shows an adult Japanese crew standing on the deck of a vessel at night. Searchlights move across broken ice. Beneath the water, a large pale shape turns once and disappears. No verified photograph, tissue sample, skeleton, sonar record, or scientific observation confirms the Nin-Jin. Most images presented online are illustrations, edited photographs, low-resolution frames, whales, seals, or naturally shaped ice. A pale whale seen through dark water can appear almost human. Its fins may resemble arms. A seal may create a similar silhouette. Rotating ice beneath the surface can look alive. The Nin-Jin remains a modern legend. Antarctic waters also gave new life to an older sea monster, the Kraken. Historical sailors described a gigantic creature capable of attacking ships. The mythical animal was exaggerated, but enormous cephalopods do exist. The colossal squid lives in the Southern Ocean. It possesses large eyes, a heavy body, powerful arms, and rotating hooks on its tentacles. Most individuals remain deep below the surface and are rarely observed alive. Giant squid also inhabit deep oceans. Scars on sperm whales reveal violent encounters with large squid in regions humans rarely see. No known squid can destroy a modern vessel, but real giant cephalopods help explain how the Kraken legend developed. The Southern Ocean remains difficult to study. Storms appear quickly. Sea ice traps ships. Cameras observe only narrow sections of deep water. Sonar detects objects without always identifying them clearly. A large signal may be a whale, squid, iceberg, school of fish, or instrument disturbance. On land, Antarctic stories focus more on unseen presences. Ernest Shackleton described one of the most famous experiences. During the Imperial Transantarctic Expedition, the ship Endurance became trapped and crushed by ice. Shackleton and his men escaped, crossed dangerous seas, and reached Elephant Island. Shackleton then crossed approximately 800 miles of the Southern Ocean in the small lifeboat James Caird. After reaching South Georgia Island, Shackleton, Frank Worsley, and Tom Crean crossed the island's frozen interior without a map. They were exhausted, hungry, cold, and almost without sleep. Shackleton later wrote that he repeatedly felt the presence of a fourth person traveling with the three men. Worsley and Crean reportedly experienced something similar. This sensation became known as the third man factor. Survivors of mountaineering accidents, shipwrecks, and polar expeditions have reported comparable experiences. The unseen presence often appears calm and supportive. Psychologists suggest that severe stress, hunger, isolation, lack of sleep, and low oxygen can alter the brain's perception of the body and surrounding space. The mind may transform internal guidance into the sensation of another person. Shackleton's account documents a powerful human experience. It does not prove the existence of a supernatural companion. Modern Antarctic stations produce similar reports. During winter, small adult crews may remain isolated for months. Aircraft cannot land. Ships cannot approach. The sun disappears below the horizon. Mechanical sounds travel through metal structures. Heating systems vibrate. Ice contracts with sudden cracks. Wind changes air pressure around doors and windows. A person may hear footsteps behind them. The sound may come from flooring, pipes, equipment, or echoes. Outside, blowing snow creates upright shapes. Searchlights project distorted shadows. Ice crystals reflect artificial light. A distant antenna or equipment cover can resemble a human figure. Isolation also affects sleep, memory, concentration, and emotional control. Station personnel may become irritable, withdrawn, depressed, or disoriented. These effects are sometimes grouped under the term winter over syndrome. Historic huts add to the atmosphere. Cold and dryness preserve tools, clothing, food containers, beds, notebooks, and wooden structures for decades. Inside an abandoned hut, a door may move because of wind. A cup may vibrate on a table. Loose fabric may shift in changing air pressure. The scene feels occupied even when no one is present. One of the oldest ghost ship legends concerns the Jenny. According to the popular story, the Jenny became trapped in Antarctic ice during the 19th century. Years later, another ship supposedly found it with its frozen crew still aboard. The captain was allegedly seated at a table beside an open logbook. The image is powerful, but reliable documentation is weak. Different versions give different dates, locations, nationalities, and details. No authenticated maritime record confirms the complete story. The legend may combine several real polar disasters. Wooden ships did become trapped in ice. Crews died from starvation, disease, cold, and shipwreck. Frozen environments can preserve human remains. The Jenny is physically imaginable but historically unverified. Other stories describe empty stations, strange radio signals, moving doors, footsteps, and equipment changing position. Most lack clear names, coordinates, photographs, or official reports. Real stations may be evacuated because of fire, medical emergencies, damaged buildings, or severe weather. Equipment can remain behind. Radio signals can also travel unexpectedly in polar environments. Atmospheric conditions, solar activity, and ionospheric reflection can carry distant transmissions into Antarctica. Static may form speech-like patterns. The brain can interpret random sound as words, a phenomenon known as auditory pareidolia. The sky creates additional illusions. Ice crystals produce halos and sundogs. Mirages stretch mountains and make ships appear to float above the horizon. The Fata Morgana mirage can transform one iceberg into towers, walls, or moving structures. Auroras form curtains of green, red, and violet light across the sky. Whiteouts remove the horizon completely. When ground and sky become the same color, distance and slope become impossible to judge. A small ridge may appear far away. A distant object may seem close. Early explorers sometimes saw people, coastlines, or buildings that disappeared when they approached. Extreme cold can damage vision. Snow blindness causes pain, blurred sight, and temporary loss of vision. Hunger, carbon monoxide exposure, dehydration, and sleep deprivation also produce confusion and hallucinations. These conditions do not mean that every report is false. A witness may honestly describe what they perceived. But a sincere perception is not always a correct interpretation. A sailor may see a pale form without identifying the animal. An explorer may feel a presence without an external person existing. A radio operator may hear a voice created by distant interference. The evidence must be examined separately from the emotion of the experience. The colossal squid is confirmed. The Ningen is unconfirmed. The third man factor is a documented psychological experience. The Jenny is an uncertain maritime legend. Historic huts are real. Their paranormal interpretations are not established. Antarctica preserves uncertainty because events are difficult to repeat. A shape may appear once beneath the water. A storm may erase tracks. A remote location may never be visited again. The continent's real isolation creates a space where perception, fear, and reality can become difficult to separate. In 1938, Germany launched an expedition toward Antarctica. The mission used the MS Schwabenland, a converted cargo vessel carrying 2 Dornier wall flying boats. The aircraft could be launched from the ship by catapult and recovered from the ocean by crane. The MS Schwabenland left Hamburg in December 1938 and reached Queen Maud Land in January 1939. The crew included sailors, pilots, scientists, photographers, and technicians. The expedition's documented objectives involved aerial mapping, geographic research, possible economic resources, and national territorial interest. Germany was particularly interested in the Southern Ocean whaling industry. Whale oil was an important industrial product, and the country wanted greater control over supplies. The Dornier wall aircraft flew across the Antarctic coast and interior. Black and white cameras recorded mountains, glaciers, exposed rock, and large regions that had never been mapped accurately. Metal markers bearing German symbols were reportedly dropped during some flights. The surveyed region became known as Neuschwabenland, or New Swabia. The expedition returned to Germany before the Second World War began. No permanent German station was established. No verified wartime document shows that a major underground base was constructed there. After the war, however, the expedition became the foundation for a much larger legend. According to later theories, the official mapping mission concealed the search for ice-free valleys, geothermal caverns, or hidden entrances beneath the mountains. Some accounts claim that Germany built an underground settlement and supplied it with submarines. The alleged base later became a refuge for Nazi officials, engineers, and military personnel after Germany's defeat. No physical evidence confirms this story. No authenticated construction plans, cargo records, personnel lists, photographs, tunnels, or archaeological remains demonstrate that such a base existed. The expedition lasted only a short time and lacked the machinery, workforce, and supply system required for a large underground complex. The theory gained new attention when 2 German submarines arrived in Argentina after the war. U-530 surrendered at Mar del Plata in July 1945. U-977 arrived in August. Their delayed surrender created immediate suspicion. Rumors claim that the submarines transported senior Nazi officials, treasure, secret technology, or supplies to Antarctica. Investigations did not confirm these claims. The crews denied visiting Antarctica. No verified navigation record shows that either submarine reached the continent. The long journeys were unusual, but possibility is not proof. Antarctic travel would have required fuel, accurate charts, polar experience, and safe access through dangerous ice. German U-boats lacked the advanced sonar and navigation systems used by modern polar submarines. Even if a vessel reached the coast, maintaining a hidden base would require continuous supplies of food, fuel, equipment, medical resources, and spare parts. A large settlement would leave logistical evidence. The theories also connected Neuschwabenland with advanced flying machines. Names such as Haunebu and Vril became central to the mythology. Haunebu is usually described as a metallic disc with a central cabin and unconventional propulsion. Vril craft are presented as smaller flying discs allegedly developed by a secret society. No authenticated wartime aircraft, engineering plans, test records, factory documents, wreckage, or working prototypes confirm these machines. Many supposed blueprints appeared decades after the war in occult or conspiracy publications. Germany did create advanced technology. The Messerschmitt Me 262 became an operational jet fighter. The V-2 rocket reached the upper atmosphere. Engineers developed guided weapons, swept wings, and experimental aircraft. These real achievements make more extreme claims appear plausible. But documented innovation does not confirm every machine later attributed to German programs. Another alleged project was Die Glocke, or the Bell. The machine is described as a heavy bell-shaped device containing rotating cylinders and an unknown substance. Stories claim that it produced anti-gravity, radiation, time effects, or advanced propulsion. The main accounts appeared long after the war and rely on uncertain testimony. No verified machine, laboratory, technical drawing, material sample, or official record confirms Die Glocke as described. Nazi Germany did operate secret facilities and weapons programs. Some used underground factories and forced labor. These facts show that secrecy existed, but they do not prove the specific technologies of the later legends. The V-2 rocket is supported by surviving components, photographs, production records, and test data. Haunebu is not. The Me-262 existed and flew. Vril disks have no confirmed prototypes. German nuclear research existed. Die Glocke remains unverified. Operation Paperclip added another layer to the story. Operation Paperclip was real. The United States recruited German scientists, engineers, and technicians after the war. The objective was to obtain their knowledge before the Soviet Union could do the same. Wernher von Braun and other rocket specialists contributed to American missile development and later to the space program. American authorities sometimes minimized parts of the recruits' political histories. This confirmed secrecy encouraged broader theories. Some argue that the United States also recovered flying discs, anti-gravity machines, or Antarctic technology. No documentation supports that conclusion. Operation Paperclip is historically traceable. The Haunebu, Vril, and Die Glocke stories are not. The Antarctic base theory combines separate real events into one narrative. The MS Schwabenland expedition becomes a construction mission. U-530 and U-977 become supply vessels. Operation Paperclip becomes proof of impossible technology. Post-war unidentified flying objects become German aircraft. Each connection depends on assumption rather than demonstrated evidence. The confirmed history remains significant. Germany conducted an Antarctic expedition. Its aircraft mapped Queen Maud Land. The region was called Neuschwabenland. German engineers produced advanced rockets and jets. 2 submarines surrendered in Argentina. German scientists were transferred to the United States. The underground city, flying discs, secret Antarctic empire, and non-human alliance remain unconfirmed. These stories survived because Antarctica was remote and poorly observed. A shadow in an aerial photograph could become an entrance. A dark valley could become a hangar. An incomplete record could become evidence of concealment. Modern satellites and international research have not identified a verified German underground complex. The mystery of Neuschwabenland therefore contains 2 separate histories. The first is documented exploration. The second is post-war mythology. The 2 became permanently connected when another enormous mission reached Antarctica soon after the war. That mission was Operation High Jump. Operation High Jump began in 1946 as one of the largest expeditions ever sent to Antarctica. The United States Navy assembled ships, aircraft, helicopters, tracked vehicles, construction equipment, fuel, communication systems, and thousands of personnel. Rear Admiral Richard H. Cruzen commanded the operation. Rear Admiral Richard E. Byrd directed scientific and technical aspects of the expedition. Byrd was already famous for polar flights and Antarctic exploration. The official objectives included cold weather training, equipment testing, aerial mapping, base construction, scientific observation, and the expansion of American knowledge of Antarctica. The operation also had strategic value at the beginning of the Cold War. Ships approached the continent from different directions. Icebreakers opened routes through sea ice. Support vessels carried fuel and equipment. The aircraft carrier USS Philippines Sea transported large R-4D aircraft adapted for polar flights. A major base was established at Little America 4 on the Ross Ice Shelf. Adult crews unloaded buildings, vehicles, fuel, radios, and scientific equipment. Aircraft began long photographic missions across the continent. Cameras recorded coastlines, glaciers, mountain ranges, and interior regions missing from reliable maps. The flights were dangerous. Whiteouts removed visual reference points. Magnetic navigation became difficult. Engines and equipment failed in extreme cold. The most serious accident involved the flying boat George I. On December 30, 1946, the aircraft struck an ice-covered ridge during poor visibility. 3 crew members died. 6 survived and used wreckage to build shelter. A rescue team reached them after approximately 2 weeks. The accident resulted from dangerous terrain, weather, and limited mapping. It was not evidence of combat. Operation High Jump ended earlier than some expected. This shortened schedule became central to later theories. According to the most dramatic claims, the fleet encountered advanced flying discs operating from a hidden Antarctic base. These machines allegedly attacked ships and aircraft and forced the mission to retreat. No verified military evidence supports this story. There are no authenticated battle reports, damaged warships, gun camera films, radar records, or casualty lists showing combat with unknown aircraft. The early withdrawal has practical explanations. Antarctic summer is short. Weather worsens rapidly. Sea ice expands. Aircraft operations become increasingly dangerous. The expedition had already completed major training, mapping, and equipment tests. Leaving before winter reduced the risk of ships becoming trapped. The military scale still created suspicion. Thousands of personnel and many vessels seemed excessive for exploration. However, a major Antarctic operation required fuel, rescue capability, aircraft support, medical services, construction equipment, food, communications, and transportation. Military organizations possessed the necessary logistics. Theories linked High Jump with Neuschwabenland. In this version, American intelligence knew that surviving German forces operated a hidden base beneath the ice. Honebu or Vril aircraft supposedly attacked the fleet. These scenes remain speculative reconstructions. Richard E. Byrd did make statements about the strategic importance of polar regions. Some quotations are presented as proof that he warned of aircraft capable of flying from pole to pole. The original context concerned future military threats. During the early Cold War, long-range bombers and missiles could approach across polar routes. Byrd's comments do not prove that he witnessed non-human or German aircraft. Another controversy concerns the alleged secret diary of Byrd. The document describes a flight into a warm region beyond the pole. According to the story, Byrd saw green land, rivers, animals, and advanced flying machines. He was then guided into a hidden world inside Earth and met representatives of an advanced civilization. They warned humanity about nuclear weapons. The diary's authenticity has never been established. It is not part of Byrd's verified expedition records. Researchers have identified problems involving dates, language, flight routes, and publication history. No authenticated original manuscript with a reliable chain of custody has been produced. The secret diary must therefore be treated as a disputed document. Its story connects with the Hollow Earth theory. Before modern geophysics, some thinkers proposed that Earth might contain large internal spaces. Later writers imagined openings at the poles leading to inner oceans, cities, animals, and civilizations. Modern seismic evidence contradicts this model. Earthquakes send waves through the planet. Their movement reveals the crust, mantle, liquid outer core, and solid inner core. Earth's mass, gravity, and magnetic behavior are incompatible with a vast empty interior. No giant opening exists at the South Pole. The pole lies on a high ice plateau. The alleged diary also connects Antarctica with Agartha. Agartha is described in modern esoteric traditions as a hidden underground kingdom. Some stories present advanced cities connected by tunnels beneath Earth's surface. The concept developed through a mixture of occult literature and adapted spiritual traditions. No radar survey, drilling project, seismic study, or expedition has discovered Agartha beneath Antarctica. Natural caves and subglacial cavities do exist. They are geological features, not proof of a hidden civilization. The high jump mythology combines several separate stories. Neuschwabenland provides the hidden base. Honebu and Vril provide the aircraft. Operation Paperclip provides post-war secrecy. The alleged diary provides a famous witness. Agartha and the Hollow Earth provide the hidden world. The combined narrative is coherent, but coherence is not evidence. Official records show that Operation High Jump was a dangerous military organized mapping and training mission. It involved accidents, incomplete objectives, and an early departure. It produced no confirmed evidence of a battle, underground city, or non-human contact. Antarctica itself was the greatest obstacle. Engines failed. Metal became brittle. Snow buried equipment. Radio communication weakened. Sea ice threatened the ships. The environment was the enemy the expedition could actually document. Operation High Jump did not solve the mystery of Antarctica. Its enormous scale made the mystery larger. Modern satellites observe Antarctica more closely than ever before. Optical cameras, radar instruments, and mapping platforms record glaciers, mountains, sea ice, research stations, and seasonal changes. This new access has also created a new generation of mysteries. People examining satellite images identify long tracks, dark objects, oval shapes, geometric formations, faces, and icebergs resembling ships. A narrow line may cross an untouched white surface. At one end, a dark object appears partially buried. Some observers describe the scene as a crashed aircraft, spacecraft, vehicle, or machine connected to an underground base. Natural explanations are often more direct. A falling rock can slide across hard snow and leave a trail. Wind may push ice or debris. Crevasses form lines across moving glaciers. Meltwater channels freeze and become visible from above. Scientific vehicles also leave long tracks. The dark object may be exposed rock. A small stone can absorb sunlight, melt the snow around it, and create a dark depression. Without scale, it may appear much larger than it is. Satellite resolution also simplifies shapes. An irregular object becomes rectangular. A shadow appears solid. Compression creates straight edges. Other images show smooth oval forms beneath snow. These are sometimes described as metallic disks. Possible natural explanations include blue ice, frozen ponds, exposed bedrock, shadowed crevasses, or wind-eroded depressions. Blue ice areas can appear dark and metallic in processed satellite images. Low sunlight creates long shadows that change with the season. Comparing multiple dates is essential. A permanent structure should remain stable. A shadow changes. Snow covers and reveals features. Glaciers move. Online maps also combine images captured on different days and with different instruments. Seams between photographs can create false walls, rectangles, repeated terrain, or missing sections. When an image is updated, a mysterious feature may disappear. Some viewers interpret this as deliberate concealment. In many cases, it reflects new snow, different lighting, improved resolution, or replacement of the satellite mosaic. Antarctic mountains also appear to contain faces. Two dark cavities may resemble eyes. A ridge becomes a nose. A horizontal shadow becomes a mouth. The brain recognizes familiar patterns inside ambiguous information. This is pareidolia. People see faces in clouds, rocks, trees, and planetary surfaces. Antarctica provides ideal conditions because dark rock contrasts strongly with white snow. The same effect occurs with icebergs. A fractured iceberg may resemble a ship, submarine, fortress, or artificial platform. Tabular icebergs possess flat tops and straight-looking walls because they break from ice shelves along large fractures. Intersecting cracks can create almost perfect corners. Geometry alone does not prove human construction. Minerals, crystals, sedimentary layers, cooling lava, and ice all produce straight lines and repeated angles. Some strange objects are clearly human. Research camps, weather stations, aircraft wreckage, Drilling sites, cargo containers, and vehicle routes appear geometric from orbit. Without information about the scientific project, an ordinary field camp can resemble a secret installation. Large research stations contain antennas, fuel tanks, generators, laboratories, tracked vehicles, and aircraft. They may look military even when their purpose is scientific. Other objects remain from old expeditions. Aircraft wreckage and abandoned equipment may become buried and later exposed by moving ice. Accurate coordinates and historical records are necessary before calling them unknown. Antarctica also contains strange biological evidence. Naturally mummified seals have been found far from the ocean and at high elevations. Their location appears impossible. Scientific studies suggest that individual seals sometimes become disoriented and travel inland through valleys or frozen channels. They eventually die from starvation, dehydration, exhaustion, or exposure. The cold, dry climate preserves their bodies through natural freeze-drying. Some remains are hundreds or thousands of years old. Radiocarbon dating shows that the seals arrived during different periods. The precise reason each animal moved inland remains uncertain, but no artificial transport is required. These mysteries are often connected with claims that Antarctica is forbidden. The legal reality begins with the Antarctic Treaty. 12 countries signed the treaty in 1959. It entered into force in 1961. The agreement established that Antarctica would be used for peaceful purposes. Military bases for warfare, weapons testing, and military maneuvers were prohibited. Military personnel and equipment could still support scientific and peaceful operations. The treaty protected scientific cooperation and the exchange of research information. It also prohibited nuclear explosions and radioactive waste disposal. The agreement did not completely close Antarctica to outsiders. Scientists, logistics personnel, private expeditions, climbers, and tourists travel there under regulated conditions. Most tourism occurs along the Antarctic Peninsula and nearby islands. Adult visitors land at approved coastal sites, clean their boots, maintain distance from wildlife, and follow environmental rules. The interior receives far fewer visitors because reaching it is expensive and dangerous. Private expeditions still travel inland, climb Mount Vinson, and reach the South Pole. Access usually requires authorization under national laws connected to the Antarctic Treaty System. Expeditions must prepare environmental assessments, waste plans, survival procedures, and emergency support. Certain protected areas require specific permits. Restrictions protect fragile ecosystems, fossil sites, microbial habitats, historic huts, wildlife colonies, and scientific instruments. A single contaminated boot can introduce seeds or microorganisms. An uncontrolled visitor can damage evidence that took millions of years to preserve. Safety also limits movement. Crevasses, storms, extreme cold, and mechanical failure make unplanned travel dangerous. Antarctica has no universal rescue service. A failed private expedition may place scientific crews and aircraft at risk. These regulations create suspicion. A permit requirement looks like prohibition. A protected area looks like concealment. Military transport supporting science looks like a military operation. The same facts can be interpreted differently when context is removed. The treaty also allows inspections of stations, ships, aircraft, and equipment by participating countries. This reduces the possibility of completely closed national military zones. Perfect transparency does not exist. Governments maintain strategic interests. Countries build stations partly for science and partly to preserve influence. Not every operational detail is public. However, strategic competition does not prove the existence of alien bases, artificial pyramids, or underground cities. A massive hidden installation would require supply flights, fuel, waste systems, communications, heat, vehicles, and personnel. Modern satellites and international observation would make long-term concealment extremely difficult. Ice-penetrating radar can reveal buried valleys, lakes, and rock structures. It does not produce ordinary photographs of buildings. Radar images require interpretation. A bright reflection may represent water, sediment, rock, or a processing effect. No alleged Antarctic pyramid, hangar, or base has been confirmed through repeated radar, seismic data, samples, and direct observation. Modern satellites have not ended Antarctic mystery. They have changed it. Earlier explorers faced blank maps. Modern viewers face endless images without enough context. A strange shape can be discovered instantly. Understanding it may require years of geology, glaciology, fieldwork, and comparison. Antarctica remains both accessible and inaccessible. Tourists visit its edges. Scientists operate at established stations. Private teams cross selected routes. Yet enormous regions remain almost untouched. The continent is protected, regulated, internationally governed, and still difficult to reach. These conditions make it a laboratory for science and a permanent source of suspicion. Antarctica preserves one of the most important physical records of Earth's past. Each year, snow falls across the continent. The layers accumulate, compress, and become ice. Inside them remain dust, volcanic ash, chemical compounds, and tiny bubbles of ancient air. Adult scientists drill deep into the ice sheet and recover long cylindrical cores. Each section is photographed, measured, sealed, and transported to refrigerated laboratories. The deeper the ice, the older the record. The bubbles contain samples of ancient atmospheres. Researchers crush or melt the ice inside controlled chambers and measure carbon dioxide, methane, nitrous oxide, and other gases. The results show repeated cycles of cold glacial periods and warmer interglacial periods. They also show the strong relationship between greenhouse gases and temperature. Recent greenhouse gas increases appear extremely rapid compared with many changes preserved in the ancient record. Some ice cores extend back hundreds of thousands of years. New projects search for ice more than 1 million years old. Researchers use radar to locate regions where the layers remain stable and undisturbed. The ice also records human activity. Lead particles reveal ancient mining. Radioactive isotopes mark nuclear testing. Industrial soot and chemicals record modern pollution. Antarctica may be far from cities, but its ice proves that the atmosphere connects the entire planet. This connection became clear through the discovery of the ozone hole. During the 1980s, British Antarctic Survey scientists measured severe seasonal ozone depletion above the continent. Ozone in the stratosphere protects life from harmful ultraviolet radiation. Human-made chlorofluorocarbons released chlorine into the upper atmosphere. During the cold Antarctic winter, chemical reactions prepared the chlorine to destroy ozone when sunlight returned in spring. Scientific maps showed an enormous region of reduced ozone above the continent. The discovery led to the Montreal Protocol in 1987. Countries agreed to reduce major ozone-depleting chemicals. Long-term measurements show that the ozone layer can recover, although the process requires decades. The ozone crisis demonstrated that human activity can damage Antarctica without physically occupying it. Local human activity creates other threats. Every ship, aircraft, food shipment, boot, and cargo container can carry seeds, insects, fungi, or microorganisms. Most introduced species die in the extreme environment. Some survive inside heated stations or milder coastal regions. Small invasive organisms can disrupt ecosystems that evolved in long isolation. Adult researchers inspect clothing, clean boots, sterilize equipment, and control imported plants and soil. If an insect is discovered inside a scientific greenhouse, the entire area may be cleaned and treated. These precautions protect the environment and preserve the scientific value of samples. Climate warming increases the risk. Species unable to survive outside a station today may establish themselves in warmer coastal areas in the future. The Antarctic Peninsula is already changing. Glaciers have retreated. Snow conditions have shifted. Ice shelves have thinned or collapsed. Large cracks extend across glaciers. Meltwater fills surface depressions and enters fractures. The weight of water pushes cracks deeper. floating ice shelves can break apart rapidly after long periods of weakening. The collapse of the Larsen B ice shelf in 2002 showed how quickly change can occur. The shelf fragmented into thousands of icebergs. After it disappeared, glaciers behind it accelerated toward the ocean. An ice shelf already floats and does not raise sea level greatly when it melts. Its loss matters because it removes resistance from land-based glaciers. West Antarctica is especially important. Much of the West Antarctic ice sheet rests on bedrock below sea level. Warm ocean water reaches beneath floating ice shelves and melts them from below. The grounding line moves inland. In some basins, the bedrock becomes deeper toward the interior. This structure can allow retreat to continue. The Thwaites Glacier is one of the most closely studied regions. Aircraft, satellites, ships, radar, underwater robots, and field teams examine its movement. Scientists lower instruments through the ice to measure warm ocean water entering cavities below. The future speed of retreat remains uncertain. Computer models produce ranges of possible outcomes rather than one exact date. The risk is serious because Antarctic ice loss affects sea level across the world. Complete melting of all Antarctic ice would raise global sea level by tens of meters, but such a transformation would require a very long time. The immediate concern is partial loss during this century and continued rise over later centuries. Even tens of centimeters increase flooding, erosion, saltwater intrusion, and storm damage. Coastal roads, ports, homes, and drainage systems become more vulnerable. The effect differs between regions because of ocean currents, land movement, and gravity. Communities with fewer resources face the greatest difficulty adapting. Antarctica may also become greener in some coastal regions. The continent already contains mosses, lichens, algae, fungi, and 2 native flowering plants. As ice-free ground expands in warmer areas, low vegetation may spread. This does not mean that Antarctica will soon become a forest. Most of the interior will remain extremely cold, dry, elevated, and dark during winter. The central plateau will remain hostile to permanent settlement. Change will be concentrated near some coasts and islands. Penguin populations will also move. Adelie penguins depend strongly on sea ice environments. Genta penguins tolerate more open water and have expanded into some regions. A warming coastline may lose one species while gaining another. Krill remain central to the Antarctic food web. Whales, seals, penguins, fish, and seabirds depend on them. Changes in sea ice and fishing pressure can affect the entire ecosystem. Human activity may also expand. Future stations could use improved insulation, renewable energy, autonomous vehicles, indoor food production, and advanced communications. Small coastal communities supporting science and logistics are technically possible. They would still depend on imported equipment, strict waste control, medical planning, and international regulation. More settlement would also increase pollution, noise, invasive species, fuel use, and wildlife disturbance. The Antarctic treaty system will face increasing pressure. Countries maintain scientific stations partly for research and partly for long-term influence. Tourism may grow. Commercial interests may seek access to biological or mineral resources. The environmental protocol prohibits mineral extraction except for scientific research. These protections do not simply disappear automatically, but future political pressure may challenge them. Antarctica has remained peaceful because nations accepted cooperation instead of military occupation. That decision must continue. The continent's future depends on climate action, controlled access, and international agreements. Antarctica's greatest importance is not limited to the legends surrounding it. Its ice cores preserve ancient atmospheres. Its rocks preserve forests near the South Pole. Its lakes reveal life without sunlight. Its glaciers influence global sea level. Its atmosphere revealed the ozone crisis. Its ecosystems show the danger of biological invasion. Its treaty system demonstrates that international cooperation is possible. Theories about artificial pyramids, Nazi bases, Agartha, the Hollow Earth, Honebu, Vril, Die Glocke, and unknown creatures remain unconfirmed. The verified continent is already extraordinary. Antarctica once supported forests. Today, it contains most of Earth's freshwater ice. It hides lakes and rivers beneath kilometers of frozen material. It records the transition from ancient natural climates to an atmosphere altered by industrial civilization. The deeper ice describes a world before humans. The upper layers record greenhouse gases, pollution, and nuclear activity. Between them lies the entire rise of human civilization. The Antarctic record is still being written. Each snowfall traps new evidence. Each glacier movement changes the landscape. Each scientific measurement reveals another part of the continent's history. The final aerial view crosses the Antarctic coast at sunrise. Dark ocean water surrounds broken sea ice. A glacier descends from the interior. Black mountains rise above the white surface. A distant research station remains illuminated. Adult scientists walk toward instruments on the snow. Far below them, ancient air remains trapped in the ice. Subglacial water continues to move. Buried valleys preserve landscapes no human has ever seen. Antarctica does not need a confirmed hidden civilization to hold Earth's true history. That history is already preserved in its fossils, rocks, sediments, atmosphere, water, and ice. The greatest mystery is no longer only what remains buried beneath the continent. It is how rapidly Antarctica will change, what its transformation will reveal, and whether humanity will protect the evidence before it disappears.